previous video you have learned about the 4 addressing modes like immediate addressing mode, register addressing mode, direct and indirect addressing mode. So indirect addressing mode, here we can see an example like if the instruction is given like move a comma r1, then here a is enclosed within parenthesis, which means that a will be having some address where the actual value will be stored. So A indicates one location where an address is being stored. Inside that address you will be having the actual value that need to be stored to R1 register. So this can be represented like this. From A you will be getting one address value. A represents an address, that is 101. In that address value, you will be in that memory location, you will be having some address. It will be pointing to 104. Here 104 is there, which is pointing to the another memory location 104, which is having the actual value that need to be copied to the register R1. Okay. The next is like register indirect addressing mode. So register addressing mode was like in the instruction directly the name of the registers will be specified and the value will be taken from the register itself. In register indirect addressing mode, operand in the register or memory cell pointed to by the content of the register Ri, which means that the register will be loading either the address or the address of any other register. Okay, so effective address will be like the content of Ri. Operand will be in the register or it will be in some memory location which will be pointed to by the register. Okay, so here if the content is given like R0 means, what does it mean? The operand that need to be fetched, it will be either in the register R0 or it will be there in R0 will be having some address. In that address the actual value will be stored. So large address space like 2 raised to n is required. Only fewer memory access than the indirect addressing. Okay, since here we are making use of register addressing mode, when compared to the indirect addressing, it requires only a fewer memory access. The example for this register indirect addressing is like in this diagram you have inside the instruction you are having some register mentioned. So inside this register, so R0 or R1, any register, it will be mentioned in the instruction. So you will be having some n registers. In that to that particular location you will be having some address value and you will be having some value, and that value will be an address. It will be pointing to the location in memory from where the actual value will be taken. Okay, so here one example what it is given is based on the registers like here move R2 comma R1. Okay, so what here it does is R2 is having some value like 3, which means that here it is pointing to the register number. Okay, so it control moves to register R3 and then R3 is having the value 5, which will be copied to the register R1. So based on the registers, the transfer is being done from R2 to R1. Okay. Then indexed or displacement addressing mode. So indexed mode is like the effective address of the operand is generated by adding a constant value to the contents of the register. So an offset field will be added, and that constant value will be taken as this x. Okay, x represents the constant value. So the notation will be like, inside the instruction, any one operand will be taking this format, x within bracket ri. Okay, so if such a notation is being given, then it means that ri will be an index register. Okay, ri is an index register, and x indicates a constant given either an explicit number, or it will be representing some name which will be having a numeric value. Okay, so x of ri means it is a notation used to represent the addressing mode, indexed addressing mode. So this notation will be specified inside the instruction in one of the operand, and if this notation is found, effective address will be computed like EA is equal to content of ry plus x, and this ri, it will be considered as an index register which will be having some memory location value. Memory location value, like if I am assuming it is to be as 1000, and if I take the x value as 4, x value if I am taking it as 4, then the effective address computed will be 1004. Okay, so inside the program, in order to update or in order to get n numbers from some array, we make use of this indexed addressing. Why this 4 is being given? Based on the size of the integer that is being stored. If it is characters being stored, means in order to get the next character, just increment by 1. If any word of characters is being stored, that is a sequence of characters in the form of string, if it is stored, means based on the string length, you can fetch the next string. So effective address will be taken like the starting address plus the displacement. Starting address means it will be having the starting address of that particular operand value in this index register ri. So index register, it holds the address of new location, and value of x, it defines the offset or the displacement. Okay, index register will be having some starting address of the memory from where the data need to be read, and x will be defining the offset value. Main purpose of using this indexed addressing mode will be to access the elements from the array. Then this also we can represent it with an example, like so instruction is having register and x, some offset is also being given. So what it does, it will be taking the content from the register. Okay, it will be taking the content from this register. So based on the previous example, the content of the register will be 1000, and 4 will be taken as x value, constant value. So the content plus this 4, content of register plus 4, you will be pointing to the memory location inside the memory, that is 1004, where the actual value will be stored. So here, if an instruction is given like this, move 3 of R1 comma R2. What is the meaning of that? R1 will be having some address. To that address, 3 will be added. Okay, so this is of the form x followed with the register R. So indexed addressing mode is being used here. Then 3 of R1. R1 is having what value? 100. So 100 plus 3, you will be getting the you will be getting the memory location 103. 103. So what is the value that is stored in 103? It will be copied to or moved to the register R2. So effective address is like index register value plus relative address. That is the constant value x. Okay. Next is like in this itself there is many subdivisions. That is index register alone, if it is used, means index addressing mode. Okay, that index register and a constant value, if it is used, means it will be called as index addressing mode. In such a case, effective address is the sum of two values. One is given inside the instruction that is specified in the register, and the other is specified inside the register. Then base with index register value. That is, you will be having a base register also, and that content will be added with the offset value. Okay, it means that base register will be having the offset value. This offset value will be stored in the base. So the notation will be like Ri comma Rj. Instead of x of Ri, inside the bracket you will be specifying two registers, where the second register Rj will be considered to be as the base register. So effective address will be like content of Ri plus content of Rj. Okay, so this form of representation will be like base with index addressing mode. So base register will be having the offset. The next notation, x of Ri comma Rj. Here three values it is being used. That is, one is the offset and the other is a base. Then the other register where the address is being stored. Effective address is like x plus Ri plus Rj, and the name given is for the addressing mode is base with index and offset. Okay, so here also a base register plus a constant value x and the starting and the register value will be taken. The EA is the sum of the constant x and the content of registers Ri and Rj. So the main purpose of using this is to access the records. If there is multiple items in a record, we make use of this record. Hoping that you are able to distinguish between the array and records. Array means same type elements will be stored. Record means you will be having different attributes stored inside the record. So in order to access the elements or different components from the record, we make use of base with index and offset addressing mode. So these three comes under the addressing mode. Next is relative addressing mode. Effective address is determined by the index mode using the program counter in place of the general purpose register. It can be used to access the data operands. That is mostly used to specify the target address in the branch instructions. Okay, so how it is being represented in the instruction is like this. We will be making use of the program counter in place of the register. Earlier, in place of this PC, we made use of register. And what is the name of that addressing mode? It was considered to be as the indexed addressing mode. And instead of register, if PC is placed, then it means that it is relative addressing mode, and purpose is to access the instructions from the memory or read the instruction from the memory, and it is helpful in fetching the instructions, that is branch instructions. So effective address is computed like EA is equal to PC plus X, where X will be a signed